Here's the code for lab number 7, where the robot needs to drive in a rectangle. Here we're hitting upload for the code. Done compiling. We'll come and look at the robot. Cool, it's ready to run. So I'm going ahead and disconnecting it and place it on our starting bracket here. There. Cool. So this inside corner is our starting of the rectangle. That first mark is exactly 24 inches away, and it should come and return exactly here. So I'm going to press the A button to begin. There's our 2-second delay. We go straight. You'll notice we'll stop exactly at the 24-inch mark and rotate. We come out. I'll complete the function. And return exactly to its initial position. So there we're about 2 centimeters off. Where did I put this? Less than 2 centimeters off from our starting location. Looking at our code, we have our constants established here, our variables established here. We use some function prototypes because we're getting some errors where Arduino wanted us to call the functions before we, or place the functions before we call them, and so we just use prototypes for that to get around that. And our setup, we just turn on an LED to let us know the robot is ready to run. From there, we use a loop function, wait for button A press and delay for 2 seconds, and then we begin a for loop, which runs us through a straight and then a rotate 4 times. So from I is equal to 0 all the way to I is equal to 3, so that's 0, 1, 2, 3, 4 times. We have our calc pulse function that allows us to calculate, based on the distance, how many pulses we need. That works if it's a positive or negative distance. And our ramp to speed function, you set the left speed, the right speed, that you just give it the variables for the left speed and the right speed. It grabs the reference for that. So you can use those global variables, and then you set your target speeds. You can additionally set ratios and your step, which is the amount it'll change every time this function is used, which we'll talk in a second, and then the slow function, which helps slow down your acceleration line if you want that. Here, it just runs through some basic logic. We used the millis function, so we didn't stop in this ramp to speed function. We can actually execute other code while this is running, but based on the slow value, every time more time has elapsed than the slow variable, it increases a step of the speed based on if you're trying to decelerate or accelerate. And then once that's done, it ups at the last update to go do that again. And at the very end, if it's very close, it'll go ahead and update it to be exactly the speed to be exactly the target speed. So that helps reduce overshooting in case you're doing some weird numbers that don't add up to exactly what your targets are. Here in a straight function, it's pretty basic. We figure if we're going forward or backwards, and then we move until we get that, and we use our ramp to speed up all the way or speed down. We do a little funky thing here with multiplying by our boolean of going forward in order to make sure that this logic works whether you're trying to go forward or backwards, while limiting the number of lines of code we're using. It's a little confusing, but we didn't want to use another if statement to do that. Here in a rotate function, again, pretty basic. We set the speeds, we set them negative to each other, and then we tell it to go. And yeah, that's how this works.